So yeah, so basically, this is what we have for vector analysis. Basically, then we have two vectors, C and D, and C is 4ax 6ay and D is 17ax minus 5ay. So basically, whenever you are trying to find out the addition or the subtraction of two vectors would be like, we need to think of them as in form of trying to join two blocks or two puzzles or two pieces of puzzles. We can have a part that goes like this, and we can have another part that goes like this. You get? Now we can call this part that goes in x. We can call this part x, and we can call the other part y. I'm not using this as an analogy. So basically, whenever you want to add two vectors, you need to plug in their parts. We have the x part of the vector, we have the y part of the vector. There's also another part of the vector which I won't even mention right now, but it's somehow like the z part of the vector or the z-axis, like, because vectors are normally how do I put it to you now? They're normally things that have magnitude and direction in all axes, because you know our plane is not really two plane, it's three plane dimensional. You get? So basically, yeah, so when you plug in or when you get the whole picture, or when you try to plug in a vector, you can get a full picture of what the product or the resultant will be like. This is just a simple analogy of what a vector will look like when you plug in, when you make the plugins, basically. So yeah, we have C, which is 4ax minus 6ay. We have D, which is 17ax minus 5ay. So basically now C minus D, you plug in, you put in the y plugins, the x plugins. For the x plugins, we have 4 and 17. So as this is minus, since our function here is minus, we have to basically subtract the plugins for the x values of each vector. So 4 minus 17 gives minus 13, and for the y plugin we have 6 minus 5, which gives minus 1. So basically, if we were to do that for the additional part, we have C plus D. So for C plus D, we're going to have 17 plus 4, and for the y part we have 6 plus 5, and this gives 21ax plus 11ay. If you were to represent this now in the Cartesian plane form, this would be how it would look like. Basically, this is how it's going to be looking like, honestly, like being honest with you guys. So yeah, but you would have to literally, this is not to scale, mind that this is not to scale, it's not to scale. I'm just trying to show you guys how it's basically going to look like if you were to draw it. It will be a kind of straight line, but this is not to scale. Yeah, just to bring that to your knowledge. But this depicts how the vector diagram will look like for the Cartesian plane on a two-dimensional plane, because the z-axis or the z variable for this vector was not actually given. You get the z variable for these two vectors were not really given. So yeah, that sums the video. Yeah.